Hi, we're going to cover the express version of sketching the graph of a rational function with two vertical asymptotes. So we're going to start by factoring your function. So if you're given this function right here, the first step is to factor it out. If you have x minus 2 as a numerator, that stays the same, and x squared minus 2x minus 3 can be factored as x plus 1 and x minus 3. Keep in mind that this will allow you to get the vertical asymptotes. So set each factor equal to 0, x plus 1 equals 0, and your other denominator, your other factor in the denominator also has to be equal to 0, and that will provide your two vertical asymptotes. So x is equal to minus 1, and x is equal to 3. So if you move forward, you have your vertical asymptotes and your domain. Once you have that, you have to go back to your original function, x minus 2 divided by x squared. So if you remember, you need to consider that the leading term has an exponent. So this is a degree 1 and a degree 2 in the denominator. So the obvious winner is the denominator, and that would cause our horizontal asymptote to be 0. The y-intercept is pretty much evaluating your function with 0. You're doing f of 0. Every x will turn into a 0. So if every x turns into a 0, you're going to end up with 0 minus 2 divided by 0 squared minus 2 times 0 and minus 3. So at the end, you get minus 2 over minus 3. That's 2/3. The x-intercept is based on what you have in the numerator. So those are going to be your x-intercepts. And in reality, it's not directly that the x-intercept is more like you're setting y equal to 0. So if y is being set equal to 0, you're thinking about 0 is equal to x minus 2 divided by whatever's down there. In this case, you're going to end up with x plus 1, x minus 3. But if you solve for x minus 2, it's going to end up disappearing. Let me show you over here real quick. So if you have 0 is equal to x minus 2 divided by x plus 1 times x minus 3. So if you solve for x minus 2, you're going to end up with 0 times x plus 1 times x minus 3 equals x minus 2. So all of this will end up as 0. So that's why the x-intercept is pretty much using the numerator. The x-intercept will be based on the fact that x minus 2 is equal to 0, and when x is 2, the entire function ends up as 0. So you get a coordinate at 2, 0. And the additional points is about finding points on every segment of the graph. So let's say we want to evaluate the function, this function, with a minus 2. So if you plug a minus 2 on this function, you're going to get minus 4 over 5, meaning the coordinate minus 2, comma, minus 4 over 5. And then if you evaluate with 4, meaning you're using a coordinate on this segment and on this segment of the graph, since we already have 2 points in between the vertical asymptotes. So the coordinate, if you plug now 4 into the function, you're going to get 4, comma 2/5. So those points are now on the graph. The sides are fairly simple to sketch. You either go above the asymptote, so you either use this segment right here, but since there is no point over there, seems unlikely. So we're gonna try to go over the point that we are given. So since the point is down here, it looks very likely that the graph will have to somehow end up down there, approaching the asymptote. And since this point is over the horizontal asymptote, seems likely that the graph would be somewhere around there. The challenging part might be the in-between. Let's use a technique that it is more based on behavior than on actual coordinates or values. So if my vertical asymptote is at -1, I'll be testing with -1.1 to see the behavior on this side of the asymptote, and on this other side, -0.9. If you want to know what the behavior is near the asymptote, since the vertical asymptote is at 3, so I can use 2.9 and 3.1. And I'll be evaluating the function with those values. So what I want to know is whether the function goes from the point, from the last coordinate, whether it will be pointing up to the positive direction or the negative direction. So if I evaluate the factor version of the function, meaning I'm going to be using f of x divided by, equals x minus 2 divided by x plus 1 times x minus 3. My goal is to substitute -1.1 here on the function. That's what is happening over here. I'm substituting -1.1 on every x. So this is where the x used to be, this is where the x used to be, and this is where the x used to be. But I'm not interested in finding the number. I'm not gonna add -1.1 or subtract -2 from -1.1. I want to know what the sign of this addition is. So if I perform that operation, I'm gonna get a negative number. If I then proceed with the next operation, meaning if I work on this operation, I'm gonna get a negative number as well. And here I'm gonna get another negative number. So that means that I'm dividing a negative number by a multiplication of two negative numbers. So this is gonna be negative. This multiplication of two negative numbers ends up as positive, and the final answer would be negative. The meaning of that is that from the last known coordinate here, and on this side, the side of -1.1, the graph will be pointing in the negative direction. So the graph will be going or pointing to -infinity. And I'm going to repeat this process by now testing with -0.9. So I substitute the 0.9 on the function. If I substitute the 0.9 on the function, once again, I'm only interested in finding the signs. So this is a negative. If I perform this operation here, -0.9 plus 1 is positive, and the next one is negative. So this ends up as negative, and that this multiplication negative as well, but the final value is positive. So that means that from that final point that I was able to obtain, I'm gonna be moving in the positive direction. Then I'm gonna be evaluating with 2.9. So my goal now is to find what happens when I'm very near this asymptote, but on the left-hand side of this asymptote. So let's evaluate the function, and I'm gonna get negative. So it means that from this last known coordinate near the asymptote, the graph is gonna move in the negative direction. And then I just have to connect the 2 points to get the behavior. So in between asymptotes, you either have a U shape opening upwards or downwards, or you have an S shape in any of those two behaviors. So that's what we want to find. And a trick here is something that will be useful is that when you have two vertical asymptotes, you're not going to expect two behaviors facing the same direction. So if you have a vertical asymptote like this, a horizontal, another vertical, if this one is already facing the negative in the negative or minus infinity direction, this has to move in the positive direction. And if you have this one up here, the other one inside of the asymptote, let me fix that, will face the opposite direction, like this. So in this case, if you notice, if this one is already facing in the negative direction, we are going to expect this one to be positive. So if we substitute a value on the equation, meaning 3.1, the answer should be positive, and that means that the graph is going to move in that direction, in the positive direction. So this is the quick and fast version of this topic.